Okay, so it's Tuesday, April 28th. We're here for Espanola Valley High School chemistry class, and today we're going to learn about molarity. Okay, now, what is molarity? Well, it's the concentration of a solution. Okay, we should understand that when a chemical reaction occurs, it very rarely occurs between, say, two solid chemicals, two reactants that are both in the solid phase. Okay, that is not to say it never happens, but it's really uncommon for it to happen. In gas phase, the reactants can both be gases. That happens all the time. Okay, so if we want a reaction to occur between two solids, for example, let's look at, say, sodium hydroxide and aluminum hydroxide, or aluminum chloride. Okay, if I get some solid sodium hydroxide, solid aluminum chloride, mix them together, nothing is going to happen. Nothing is going to happen. But yet we know that a reaction will occur. We should recognize this as a double substitution. So the aluminum will hook up with the hydroxide. Hydroxide is insoluble, so the aluminum hydroxide will precipitate out. So this is a double substitution precipitation reaction. Okay, but how can I get this to happen? Well, remember, it's the aluminum cations reacting with the hydroxide anions. The reason the reaction does not occur in the solid phase is because here in the solid, the aluminum is bonded to the chlorides. Over here, the hydroxides are bonded to the sodiums. So we have to break those up. We got to separate the aluminums from the chlorides also. So we do that by dissolving it in water. Okay, so when we dissolve it in water, as we know, this breaks up into sodium cation and hydroxide anion. This breaks up into aluminum cation and then 3 chlorides. So now that we have these 4 ions floating around in solution, now the aluminum can bump into the hydroxide. This is why so many chemical reactions occur in solution. All right, and the type we're interested in occur in aqueous solution, which means water. Aqueous means water. Okay, now the question is, if I wanted to do this reaction, how much sodium hydroxide do I use? How much aluminum chloride do I use? How much water do I use? Okay, so we can specify that by a quantity called the concentration of the solution. The concentration. Okay, in concentration, if you think back way back into September of the beginning of the school year, we saw that we defined density, and you don't need to write this down. We defined density as mass divided by volume. Okay, well, today we're going to take a look at, there's 6 or 7 ways to express concentration, but the one we're going to look at is molarity equals moles divided by volume. So this looks very similar to density. So when we express the concentration of a solution, we're talking about the number of moles of whatever it is we're trying to dissolve, which is called the solute. So I'll put moles of solute. All right, so if we're dissolving sodium chloride in water, the sodium chloride would be the solute, divided by the volume, not of the water, but of solution. All right, we'll talk more about this in a few moments. Okay, so moles of solute divided by volume of solution. This looks very similar to our equation for density. Remember, mass is a measure of the amount of matter in an object. Well, moles, in a way, measures mass, right? We can do this conversion back and forth, as we learned last week, from grams to moles or moles to grams. So in a way, they're kind of measuring the same thing, right? So it looks very similar to our density equation. Okay, and again, there's a number of different ways to express concentration. One is percent weight to weight, percent weight to volume, percent volume to volume, but we won't really talk about this. Molarity is far and away the most common one if you're working in a chemistry or a biology lab. Right now, when we go to actually work some problems with this. Instead of writing volume here, I'm going to replace it with liters, because in this molarity equation, this volume is always measured in liters. But sometimes I'm going to give you the problem in milliliters. So I want you to remember this in terms of liters. If I write volume here and we work it like that, quite often students will forget to convert the milliliters to liters. So their answer will be off by a factor of 1,000. Okay, so we're going to get started here. Let's look at a problem. There, we'll start out with some easy ones and then build up to harder ones. Okay, so we'll give you a chance to copy that down. Okay, so it says, what is the concentration? Well, that sounds like I'm looking for concentration. So concentration equals the question mark of a solution containing 6.24 moles. All right, so we'll write moles equals 6.24 moles. Dissolved in 800 milliliters of solution. So I'm going to write liters. Now I have to convert 800 milliliters to liters. Remember, a milliliter is a very tiny volume, right? Very tiny volume. But a liter, you know how big a 2-liter bottle of soda is. So there's many more milliliters in a liter than vice versa, right? So milli means 1,000th. So like a millennium has 1,000 years. So there's 1,000 milliliters in 1 liter. So to convert this 800 into liters, I have to divide by 1,000. So over here, I'm going to write liters equals 0.800, and I'm running out of room, liters. Okay, so we'll put our equation up here. So concentration equals moles divided by liters. And as always, it's been a while since we worked word problems. We're going to check off what we know and what we don't know. Over here, I do not know the concentration. I do know the moles. I do know the liters. All right, so I asked myself, is concentration in the numerator? Yes, it is. Is it by itself? Yes, it is. So I go ahead and plug the numbers into the equation. So let's go ahead and do that. Concentration equals the moles written right there, 6.24 moles. And divided by the liters, which is 0.800 liters. All right, and then I'm going to get out my calculator. So 6.24 divided by 0.8 equals, and I get 7.8. Now pay attention here. 7.80. Okay, because I have 3 digits here, I have 3 here. Remember, the leading 0 doesn't count, but the 2 zeros at the end do. That is if I put a decimal point there. Okay, now, what are the units? Well, I always tell you guys, look at the line above. I didn't cancel the moles, I didn't cancel the liters, so my units here should be moles divided by liters, which they are, but I'm not going to write that. I'm not going to write that. I'm going to write this unit called molar, like your tooth, molar. Okay, and let's see why that is. Let's see why that is. To do that, I'm going to get out my little board here. and we'll take a look. Now, in this country, we use pounds. Someone says to you, how much do you weigh? You say, oh, I weigh 120 pounds, whatever. Okay? But in the rest of the world, they don't use pounds, they use newtons. Okay, pounds and newtons are a measure of force. So, but what is a newton? Well, let's see, force equals mass times acceleration. So this is measured in newtons, and mass is measured in kilograms, and acceleration is measured in meters per second squared. All right, so if you go to Europe or somewhere, Asia, and they say, how much do you weigh? You're not going to say, I weigh 120 pounds. You're going to say, oh, I don't know, I weigh 847 kilograms times meters divided by second squared. Well, that's a mouthful. No one says that. They would just say, I weigh 874 newtons, because a newton is equal to this on the right-hand side. So this is a newton is what's called a composite unit. It's made out of other units. It's made out of other units. So it's easier just to say this than to say all this. Similarly, we talked about joules back in, I don't know, early October or so. So a joule is just a newton multiplied by a meter. So instead of meters, it's meters squared. Right? So no one says, how many joules does that light bulb burn up in an hour? Okay, they would just say joules. They wouldn't say how many kilograms times meters squared per second squared does that light bulb burn in an hour. They would just say how many joules. Okay, so does everybody understand this? Okay, thumbs up if you understand. If not, then don't put a thumbs up. Okay, so this goes back to here. Right, we just say 7.80 molar rather than 7.8 moles per liters. Right, just the easier way of saying it. Right, just the easier way of saying it. Okay, but I want to point out a few things. This is a very simple problem. We didn't have to rearrange the equation at all. But I want to point out a few things. We did have to convert the milliliters into liters by dividing by 1,000. By dividing by 1,000. And let's see, always write the units in. We didn't need to rearrange the equation here. And again, we used the composite unit rather than moles per liter. Okay, so I'm going to erase this. We'll move on to the next problem. That's a very, very easy problem. You know, believe it or not, when last year there was a question just like that on the EOC. Just like that one, and then just like this next one. And here we'll put the formula for calcium nitrate. Oh. Here, let's do this. All right, so we'll give you a chance to write that down.
What's written after required to?
Required to make 256 milliliters of 2.75 molar solution. So on the assignment that you have to do, there's one or two problems like the one we just did, and then one or two like this one, and then one or two like the next step. Next step will be even a little harder. Okay, so let's take a look here. How many grams? Well, that sounds like mass to me. So over here, I'm going to write mass equals question mark. calcium nitrate are required to make 256 milliliters. So liters equals not 256, but 256 divided by 1,000, which is 0.256. And I've run out of room here, so I apologize. I like to write everything on one line there. 0.256 liters of a 2.75 molar solution. Now pay attention here. I'm going to write concentration equals 2.75, but I'm not going to put molar. I'm not going to put molar. I'm going to change it to moles divided by liters, because that's what molar means. And we'll find out why I did that in a few minutes. All right? You should never put molar into an equation. It's okay in your final answer, like it was in the last problem. But when you're working with an equation, always change it to moles per liter. And again, we'll find out why in a moment. Okay, so let's take a look here. All right, we're going to write our equation for concentration equals moles divided by liters. And as always, I'm going to check off what I know and what I don't know. Well, let's see. I know the concentration. I know the liters. I do not know the moles. I do not know the moles here. So I can rearrange this equation and solve for moles. All right. Oh, wait a second. Okay, yeah, we can do that. We can go ahead and solve for moles. So I'm going to move liters over to the other side. All right. So I'll move liters over to here. Times concentration equals moles. All right, now moles is in the numerator and by itself. Okay, moles is in the numerator and by itself. But remember, we don't want moles. We're actually looking for mass. But if we find the moles, then we can convert the moles into mass using a mole concept problem, like we learned last week. Now I'm going to flip this. I always like to have my unknown on the left-hand side. So let's go ahead and flip this first. Moles equals liters times concentration. Now you shouldn't crowd everything together. I don't have any choice because I just have this small board to work with here. Okay, so I go ahead and plug in now. I'll pick a different color. So moles equals the liters right there, 0.256. And then the concentration, which has a clear numerator and a denominator. So 2.75 moles divided by liters. Moles divided by liters. Now, let's take a look. We'll give you a chance to get caught up there. And we ask ourselves, can I cancel anything? Well, I see liters here and liters here, so I can cancel those. But now I want to point out, before I cancel them, I want to point out something to you here. This is why when we wrote the concentration here, we did not write 2.75 molar. We changed it to moles per liter. If I had written 2.75 molar here, then these liters would not cancel with these liters. Remember, the left side of an equation must equal the right side, including the units. If I had written molar here, we would have moles equals liters times molar, which makes no sense. We want moles equals moles. Okay, so when I change the molar to moles per liter, these liters cancel with these liters, and I'm left with moles equals moles. Okay, all right, now all we got to do is get out our calculator. So moles equal 0.256 times 2.75. And I get 0.704. 0.704 moles. And again, I apologize that everything is running together, but I picked different colors, so you should be able to see which line is which line. But on your paper, you should not be cramming everything together. Okay, so now we have successfully solved for moles, but we have not answered the question, the problem, solved the problem. The problem wants to know how many grams, the mass. not moles. So all I have to do is a mole concept problem, take this 0.704 moles, convert it into grams. Right? So I'm going to get out the little board here to do that. All right, we'll leave this up here. Okay. All right. But first, we're going to need the molar mass of calcium nitrate, right? For a mole concept problem, we need the molar mass. So let's go ahead and do that. So calcium nitrate. So calcium, nitrogen, and oxygen. I see 1 calcium, 1 nitrogen times 2 is 2 nitrogens, 3 oxygens times 2 is 6 oxygens. So calcium is 40.078, nitrogen is 14.007, and 15.999 for the oxygens. That's going to be 28.014. That's going to be 9695.994. All right, we get out a calculator and add them up. All right, I get 164.086 grams. 164.086. I know I'm going to need that number in the mole concept, so I'm going to put that into my first memory. That number goes into my first memory. No point in typing it in again when we know we're going to need it. Okay? Now, I'm going to erase this molar mass calculation because I'm going to need this small board for the mole concept problem. Get our final answer. So this is a two-step problem here. All right, so we want to convert the, what was it, 0.704 moles into grams. So that's like how many grams are equal to 0.704 moles. We're going to convert the grams to moles. Copy the, the moles to grams. Copy the units over to the other side. I'm going to have to write very small here, grams, moles. The right-hand side is my 1 mole side. How many moles are in 1 mole? 1. How many grams are in 1 mole? The molar mass. We just calculated 164.086. 086. Actually, here, let me do this, make it a little clearer. Equals 164.086 grams. Okay. So again, we copy the units over to the other side, and then we ask the question, how many moles in 1 mole? How many grams are in 1 mole? So X is in the numerator, not by itself, so I need to move the 0.7 moles over to the right-hand side. So let's go ahead and do that. And again, I got to write very, very small, 0.704 moles. I'm sorry if you can't make that out, but just remember, you have it right here, 0.704 moles. Okay, so I move that over to the other side. Okay, and here I have moles and moles, so I can cancel the moles. Right, so underneath, write what's left, X grams equals. All right, the only unit I have left, I canceled these moles with these moles, so the only unit I have left is grams. Left side must equal the right side, including the units. So all I got to do is multiply the molar mass times 0.704. I have the molar mass in my first memory, so recall 1 times 0.704 equals, and I get 115.5. Now we should probably round that up to 116 because I like to do this approximately 116 grams. because in our original problem, I had 256 3 digits and 2.75 3 digits. So my answer here should really only have 3 digits. Again, if you put more, I won't mark it wrong. Right? It's better to have too many than too few. Right? So there's my answer. How many grams? There's the grams. So again, this one requires a little bit of thinking. We first had to find the moles, right? With a concentration problem. And we made it a molarity problem. Found the moles. Once we had the moles, 0.704, then we did a mole concept problem to convert the moles into grams. Okay, so this was a two-step problem. Any questions or comments? Any questions or comments? If you're good, let's see a thumbs up. If not, ask a question.
I missed the mole concept. Could you send me that recording?
Yes, I will. I'm not going to ask for names right now, but at the end, tell me your name and I'll send it after I stop the recording, okay?
All right, great, thanks.
Because I think I'm going to actually put them on YouTube. Okay. All right. Any other questions or comments here? Any other questions or comments? All right, so I'm going to erase this. We'll do another one. This problem here is a bit more realistic than the first one that we did. Right? It's a bit more realistic. Because in the laboratory, you know, you go get a jar, the jar says grams on it. You weigh out grams on the scale or balance. Okay, you don't weigh out moles. So in the first problem, I told you the amount of the chemical in moles. This problem, generally you decide, okay, I have to make a solution. I know what volume of the solution I need, right? And I know what concentration I want it to be. So then you have to do the calculation, how many grams of the chemical am I going to need to make that solution? So this is a more realistic calculation in the laboratory. Okay. And then we'll look at this third one, which also is a real problem in the laboratory, but not as common as this one that we just did. All right. So you might go get a jar of chemical and there's not much left in it. And you might say, well, okay, if I use this chemical, there's only going to be a tiny bit of it left in the jar. Why put that back on the shelf? I'll just use it all up. Right? So you know what concentration of this solution that you need. You know what concentration you need. And now you know the mass. You now know the mass. So now what you want to do, if you say, okay, I'm going to use all the chemical that's in the jar. Now, again, so you know the mass in grams, you know the concentration, so what's left? The volume in liters. So you say, okay, how much solution can I make with this amount of chemical? What's the most volume that I can make, right? So quite often I find I've had to do that, okay? When there's just, you know, you have a big jar and you don't want to put it back on the shelf with just this much chemical in it. You just say, I'll use all the chemical, okay? But then that changes the volume that you're going to need. So let's think of a problem here. So what volume of a all right, there we go. So there's the problem. I'll give you a chance to write it down. Let me get a bit more water here while you're writing. Okay, so hopefully you have all that. So what volume? That sounds like I'm looking for liters, right? That sounds like I'm looking for liters. So liters equals a question mark. Of a 3.75 molar solution, so I know the concentration, equals 3.75. But again, I'm not going to write molar over here. I'm going to change it to moles divided by liters. Moles divided by liters. Because then I see these liters can cancel with those liters there, or something akin to that. Okay, can be prepared from this many grams of magnesium cyanide. So I know the mass. Mass equals 78.5 grams. Now, if we want, well, we'll just leave it at that for the moment. Okay, so I'm going to go ahead and write my concentration equation. So let's proceed to do that. Concentration equals moles divided by liters. Okay, let's check off what we know and what we don't know. Well, let's see. I know concentration. I don't know moles. I don't see moles written over here. And I don't know liters. Oh. Everybody still there? Okay, I lost the screen there for a minute. I hope it's still recording okay. 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 So now this problem is a little different. I have two question marks here. I cannot solve this problem. All right. So what that tells me is this is going to be a two-step problem. I have two unknowns. So I'm going to somehow have to figure out what one of them is, take that and come back to this equation. All right. Well, let's see. I don't know moles, but I know the mass. So I can do a mole concept problem here. I can do a mole concept problem, convert these 78.5 grams of magnesium cyanide into moles. Then I can come back and replace this question mark with a check mark. Then the only unknown I will have is liters. Right? This is very important. I'm going to say that again. It's been a long time since we've done anything like this. I have two question marks here. I cannot, actually, there's an infinite number of solutions. But we're only interested in one. So effectively, we cannot solve this problem with two unknowns. Okay? So again, that tells me I have a two-step problem. I have to go off, I have to pause this equation for a moment, go and figure out either the moles or the liters, and then come back to this equation. All right? And here, how do I know? Do I solve for moles or liters? Well, here I look over here, what's given to me. Here I have mass. I know I can convert mass into moles using a mole concept problem. So let's go to the little board and do that. Well, the first thing I'm going to need the molar mass of magnesium cyanide if I'm going to do a mole concept problem. So magnesium cyanide. All right, so Mg, carbon, and nitrogen. Magnesium 1, cyanide. There's one carbon times 2 is 2 carbons. One nitrogen times 2 is 2 nitrogens. All right, carbon is 12.011, nitrogen is 14.007, and this is, I think, 0.305. Yes. So 24 0.022, 24, 0.305, and 28.014. Get the calculator out and add them up. All right, put that in my memory, 76.341 grams. Now, I've only been doing these calculations once. You should always do them twice. In the interest of time is why I'm only doing them once. Okay? All right, so I put that into my first memory because I know I need it for the mole concept problem, right? So let's make sure I did that, store 1. Okay, now I'm going to do the mole concept problem on this little board. So I'm going to have to write kind of small. Okay, are we good here? All right. Write kind of small. Okay, so again, we're going to convert these 78 grams into moles. So that means I don't know the moles. That's my X moles. X moles, but are equal to 78.5 grams. So there is my left side of my mole concept problem. Whoever that was that said they don't understand mole concept, pay attention right here. Here it is. All right, I'm going to convert X. I want to find moles. How many moles are equal to this many grams? So immediately, I copy the units over to the other side. Moles and grams. Moles and grams. Okay? Because left side must equal the right side, including the units. Now, this is my 1 mole side, and every one of these problems, right-hand side, is going to be my 1 mole side. How many moles are in 1 mole? 1. How many grams are in 1 mole? We just calculated that, the molar mass, 76.341. Right? 76.341. Now, X is in the numerator, but it's not by itself. It's being divided by these grams. So I need to move these grams over to the right-hand side. And when I move them, they're going to change from denominator to numerator. Written clearly in the numerator. Clearly in the numerator. All right. So what may I cancel here? Well, I move this over to the right-hand side so I can get rid of it there. Here I have grams in the numerator and grams in the denominator. I can get rid of those. All right. So underneath, I'm going to write what's left. Only thing on the left-hand side is X moles. Every mole concept problem is exactly the same. My only unit left here is moles. All right, because I canceled the grams. So now all I got to do is 78.5 divided by the molar mass. Oh, it's almost 1 now. I didn't mean for it to be like that. And I have this in my memory. So 78.5 divided by recall 1 equals, and I get 1.03. I only have 3 digits here. I can only have 3 here. Okay, again, I won't mark you wrong for that. We never did cover significant digits. I'm going to put this into my first memory, store 1. Put that into my memory. Okay, everybody has this copied down. Thumbs up if you're caught up. Okay, looks good here. All right, I'm going to take her away. All right, so again, I have the moles in my memory. And I'm going to write it here. Moles equals 1.03 moles. All right. And then I'm going to come back to my equation here. And on the moles, I'm going to replace that question mark with a check mark. Replace the question mark with a check mark. Now, we only have 1 unknown. We can work with this. There's only 1 unknown. Okay? So I asked the question, is liters in the numerator? No, it's not. So I'm going to move liters over to the left-hand side. Now we'll put it in the numerator, because when it changes from one side to the other, it's going to change place with respect to denominator and numerator. So I'm going to write liters times concentration equals moles. All right, liters is in the numerator. It's not by itself. It's being multiplied by concentration. So I need to move concentration over to the other side. And when I move concentration over to the other side, it's going to go into the denominator. Right? So I'm going to do that now. Concentration. Right? Move concentration over to the other side. So I'm going to write what's left. Liters equals moles divided by concentration. All right. So now I ask the question, is liters in the numerator? Yes, it is. Is liters by itself? Yes, it is. So now I can plug the numbers from the right-hand side into this equation and get my final answer. So let's proceed to do that. Liters equals moles, right there, 1.03. I also have that in my calculator memory, divided by the concentration, which is 3.75 moles per liter. Okay. Now, here we have one fraction being divided by another one. So there's our A over B, our first fraction. There's our bottom fraction, C over D. We should do A over B over C over D. Actually, we will do that, but I'm not going to ask you to do that on your papers. All right. Again, let's go ahead and do that. And to do that, I'm going to do it on the small board here. All right. So we're only interested in the units here. So moles is A. Again, that's the top fraction. So B is just 1. This is really moles divided by 1. So B equals 1. C is moles, and D is liters. All right? So I'm going to go ahead and do that on this smaller board. The smaller board here. All right? I have the feeling some of you are probably still copying, so I'll erase this here. Okay. So again, that was A over B was, here, let's put this up here. A over B over C over D equals A over B times D over C. So A over B was moles divided by 1. And D over C was liters divided by moles. All right? I can see here that the moles are going to cancel. The only thing left is liters. The only thing left is liters. Again, I won't ask you to do this, but you should know how to do this. You guys are in high school. I mean, this is like a 5th or 6th grade problem, dividing fractions. You should know how to do this. Amazing how many of my science majors at the college can't do this. Okay, so I know that this set of units is going to reduce to liters. All right, now I've run out of room. All right, you should be going straight down to paper. I've run out of room, so I'm going to bring it over to here. All right, so I'll put my final answer here. Liters, and again, I apologize for that, but my board is only so big. So liters equals liters. We just showed that combination of units is in fact equal to liters. So now just the moles divided by the concentration. So, and I have the 1.03 in my memory, divided by 3.75 equals, and I get 0.274. Okay, I'm sorry, again, I keep apologizing. Hopefully you guys can read all this stuff. I don't have a whole lot of room to write. Okay, any questions here? This is about as hard as it gets. Okay, this is as hard as it gets. No problem harder than this one. All right. Let's see. So we're at 223. You want me to do one more? Or are there any questions or comments here? let's just run through this one. Since I said this is about as hard as it gets, let's run through what we did on this one. How did we finish it? This was a couple steps. Okay, notice this also combined molar mass, mole concept, and molarity, right? So the last three assignments we needed to know how to do this problem. All right, so we were looking for a volume, liters. We were given a concentration, and we were giving the mass of the sample. So we set up our equation for concentration, solved it for liters, but we saw there were two unknowns. So we had to go, and unfortunately I had to erase it, we had to go and solve for moles. We had to convert the grams here, the 78.5 grams into moles using a mole concept problem. We solved that, wrote it here, 1.03 moles. Then we could replace the question mark on the moles with a check mark. Then we only had one unknown on the liters. Rearrange the equation, solve for liters, right? Move liters over to the left, get it in the numerator, move concentration over to the right to get liters by itself. The liters in the numerator by itself, plug in the numbers, we're done. Plug in the numbers and we're done. Again, I said you don't have to do this A over B over C over D. If you want, you can just look liters, and you know the right-hand side should equals liters, and there is a combination of moles that will do that for you. Okay, any questions or comments here? Any questions or comments? Let's see, did anybody else check in 14? No, everybody, nobody left early. Okay, well, that's good. That's good. I think maybe you were wise to stick around for this. Shall I do one more? You want to see more? One more, give me a thumbs up. If not, then we'll stop.
Can you do another like this one?
Like this one? Okay. All right. All right, somebody checking in or out. Let's see. All right, so there we go. We'll give you a chance to write it down. And I'm going to get the small board ready. Oh, my apartment's getting hot already. What am I going to do in July? Okay. 100 degrees already in Phoenix. Okay. So let's go ahead and read this. How many liters? Well, that sounds like my unknown. So liters equals a question mark of a 0.675 molar solution. So now I know the concentration. 0.675, but I'm going to change that molar to moles per liter. All right. Can be prepared, and we're given the mass of sodium chloride. So mass equals 30.25 grams. Okay. So now I'm going to write down my equation for concentration. Concentration equals moles per liter. Okay. I look on the right-hand side. Well, I know the concentration. I don't know the liters, question mark. And I don't even see the moles written there, so there's no way I can know the moles. All right? So again, we have two unknowns, which requires us to figure one of them out. I'm given the mass using a mole concept problem. I can convert that into the grams into moles. So I'm going to go ahead and do that on the small board. Okay? Again, when you see two question marks like that, don't give up. The information is going to be there for you to figure out one of them. And lo and behold, it is. We're given the mass. So let's see here. So we need the molar mass of sodium chloride. All right, 1 sodium and 1 chloride. 22.9898 and 35.45. All right, let's get the calculator. I was going to do it in my head, but why do that? We got a calculator. All right, put that into my memory. 58.4398 grams. Always write the word grams. And I'm going to put that into my memory. Store 1. Okay. Okay. So I'm going to erase this and we'll do the mole concept part now that we know the molar mass. So I want to find moles and I know the grams. I want to find moles. So that sounds like my X moles. And I know the grams, 30.25. That's why it's nice to have everything written right there. Equals, copy the units over to the other side. Moles, grams. All right? So the right-hand side is my 1 mole side. How many moles in 1 mole? How many grams in 1 mole? Well, how many moles in 1 mole? Duh, 1. How many grams in 1 mole? Well, we just calculated the molar mass. 58.4398. 58.4398. Okay, and again, every one of these molar mass problems is the same. X is in the numerator, not by itself. So I need to move these 30 grams over to the right-hand side, where they will go from denominator here to numerator on the other side. So 30.25 grams. Okay. And let's see, here I see grams divided by grams. So I can cancel those. And here I already moved the 30 grams over to the other side. So I can get rid of those there. Okay. Underneath, we're going to write what's left. X moles equals, I canceled the grams, so my only unit left is the moles here. All right, just get out the calculator now. 30.25 divided by the molar mass. 30.25 divided by recall 1 equals 0.518 moles. I'm going to put that into my first memory. Put that into my first memory. So why only 3 digits here? Remember, the leading zeros don't count. Why 3 here? I have 3 here. The leading 0 doesn't count. So 1, 2, 3. But here I have 4. I choose the one that has the fewer number of digits. So 3 is less than 4. So my answer should only have 3. Again, the leading zeros don't count. But again, I will not dock you points for that, right? Because we never have formally covered significant digits. All right, so I have this in my memory, first memory. So I can take this down. And now I know the number of moles. So I can go ahead and write that here. Moles equals 0. And I have it in the memory, 0.518 moles. And up here, I'm going to replace the question mark with a check mark. All right? Replace the question mark with a check mark. Now, here, we're back to here now. I have a single unknown. Is liters in the numerator? Remember, that's always the first question you ask. No, it's not. So I'm going to move it over to the left-hand side to get it into the numerator. All right, get rid of it there. Underneath, I'm going to write what's left. Liters times concentration equals moles. Right? Our unknown, liters, is in the numerator, not by itself. So I need to move concentration over to the right-hand side, where it will go into the denominator. Now, I really got to start crowding stuff together here. So I'll pick a different color here. So liter equals moles divided by concentration. So liters is in the numerator and it's by itself. So we can go ahead and plug the numbers in from the right-hand side. So liters equals moles is 0.518. Divided by the concentration, which is 0.675 moles per liter. All right, and again, I'm going to bring it up here because I have run out of room. So liters equals. Now, I'm going to go ahead and cancel these moles here. We're not going to do the A over B over C over D. We just did that on the last problem. Remember, this is C over D, so that means the liters will come up into the numerator. So I can go ahead and write liters as my unit on the right-hand side. So liters equals liters. Now let's just get out the calculator. I have the 0.518 in my memory. So recall 1 divided by 0.675 equals, and I get 0.767 after rounding. 0.767. Okay, and we're done. Any questions or comments? Any questions or comments? We're all good. All right, I'm going to stop the recording here.